All right, folks, moving on to section 8.2. 8.2 involves the Pythagorean theorem. Now, what's crazy is we've been using the Pythagorean theorem all year, and now they finally formally introduce it. So what we have here is a squared plus b squared equals c squared. So this is the formula that we're going to use, and then this is an example of a pictorial. C, the side that's by itself, is always opposite your 90 degrees. A and B is kind of interchangeable. So that one doesn't really matter where it goes. But again, this only works for right triangles. A squared plus b squared equals c squared. So let's give you one quick example here. I don't think this is on the note sheet, so kind of add this one in. But here's your 90-degree angle. You go across from that. That one's by itself. So you're going to go 4 squared plus 7 squared equals x squared. So as long as you have the 90-degree by itself, the other two here can figure it out. So you go 4 squared plus 7 squared. So the 4 squared here is 16. The 7 squared is 49. 49, that equals c squared. Add those two together. 4, 5, so 65 equals c squared. So how do you get c by itself? Is we take the square root of both sides. And the square root of 65 is, hopefully you can figure out how to do that on a calculator. I have about 8.06. So C is about 8.06. So hopefully that you're figuring that out, how to do that, and we're good to go from there. Next one here, so this one has square roots in it, but let's just get started. Here's your 90 degrees, so that side is opposite, so 6 squared plus x squared equals 12 squared. So whatever's opposite your 90 degrees is by itself. So again, here's where you do the multiplication. 6 squared is 36, plus x squared equals 12 squared, which is 144. You subtract the 36 over, so I have x squared equals 108. From here, how do you undo a squared? You undo it by square root. So x would be about, so in terms of a decimal, x would be about 10.4. Now, if you're going to relate this, though, to how does this work with one of those problems on the board, you could take and multiply all those, or some of you have a calculator that reduces those for you, or you take that 108, you write it as a product of primes. But ultimately, what you find is your answer would be B in this case. So again, it's one of those things where you have to try to get your decimal to match up with a multiple choice question, which has a square root in it. Next thing here is the concept of a Pythagorean triple. Basically, a Pythagorean triple just states that any of these numbers that are set up this way, you could put into a right triangle. And so one side is 3, one side is 4. The biggest side is always opposite your 90 degrees. So that's an example of a Pythagorean triple. So if you did the math, this would work. 3 squared plus 4 squared equals 5 squared. The reason it's called a Pythagorean triple is because all three numbers are whole numbers, and all three, when they squared, are equal, and they finalize or form use the Pythagorean theorem correctly. So you don't see this very often, but when you see a problem that says use the Pythagorean triple, means that it will work. It means that it's also a whole number, an integer, not a decimal. So we would go 24 squared plus x squared equals 26 squared. And so you would just go through this and do the math. If you had a chart, you could look in the chart and see that the answer is 10. But I assume you're not going to have a chart with you every time you do this. So in this specific example, you just go through and do the math. And if they tell you that it's a Pythagorean triple, that just means that you're going to have a whole number. So 26 squared is 676. We still have the x squared. And the 24 squared is 576. So you subtract that over, x squared is 100, square root both sides, and x is 10. So yes, we found that it's 10. Yes, they're all whole numbers, so yes, it's a Pythagorean triple. Same concept here. Use a Pythagorean triple to find x. So again, x squared plus 36 squared equals 39 squared. So again, you do the math. 39 squared is 1521. 36 squared is 1296. And x squared with it, you subtract over. So we have x squared is going to equal 225. And when you square root that, you find that the answer is B, which is 15. Now they're going to apply it to a real life type of a story problem here. So in this example, here's your 90 degrees down here. So you're going to go x squared plus 16 squared equals 20 squared. And again, you're doing the math. You're using your calculator. Do what you got to do. X squared plus 16 squared is 256. 20 squared is 400. You subtract over, you find that x squared equals 144. When you square root that, final answer is 12. And that should be with units. So this one they don't give you a picture of, but same idea, a 10-foot ladder. So you have to understand, here's the building, there's the building, okay? A 10-foot ladder. So this is the ladder right here. That's the ladder. So this is 10 feet ladder is placed against the building. The base of the ladder is 6 feet. So this right here is 6 feet from the building. There's your 90-degree angle. How high does the ladder reach the building? So there's your x. So you have to be able to set up a problem and use it along the way. X squared plus 6 squared equals 10 squared. X squared plus 30, x squared plus 36 equals 100. Subtract over. We get that x squared is 64. You square root both sides, and you find that x is 8. And in this case, we want the units with that, so that would be B, feet. Just again, the converse. So if you set this up, then you know that it is a right triangle if you're able to get that to work. And then now we have a concept here, the Pythagorean inequality theorem. So again, they're going to give you 3 sides. If you find that the square of one side is less than the square of the other two added together, then we have an acute triangle. If you find that a side by itself is greater than the other 2 sides squared and added together, then we have obtuse. If they are equal, then it is a right triangle. There's one test we're going to do first to get started, though. And the first test is you have to make sure that the sides that you have actually form a triangle. And if you remember when we did this before, you have to take the longest side, and you have to, in relation to, the longest side has to be bigger than, or has to be smaller than the other 2 added together. And if it is not, then therefore it will not work. So this number has to be less than the 12 plus 9. So is 21 greater than 15? That's a yes. If that answer is a no, then you cannot form a triangle. So always start with that test first. Then now we go to the actual test. I think it's on the next slide here. So yeah, so you have 15, 12, and 9. So you put 15 here. You have 12 squared. You have the 12 squared plus 9 squared, and you find out they are equal. Since those 2 are equal, we have ourselves a right triangle. So let's try the next one. We have 10, 11, 13. So is 13 less than 10 plus 11? And that answer is a yes. So we want to proceed. We need to continue now. So you take that 13 squared. What is that in relation to 10 squared plus 11 squared? Okay, so we have 13 squared is the 169. 10 squared is 100. 11 squared is 121. So we have 169. 169 is less than the 221. So therefore you have an acute. The side by itself is smaller than the other 2 squared and added. We have acute. And again, there's work justifying that right there. So again, let's take a look at this one here. Take our 3 sides. 14 has to be less than 7 plus 8. Is that true? Yes, it is. So what is 14 squared in relation to 7 squared plus 8 squared? Okay. We have 14 squared is 196. 7 squared is 49. 8 squared is 64. Add those two up, you get 113. So 196 is greater than 113. So therefore, this is obtuse. This is obtuse. Last one here, folks. Again, take a look here. 33. 33 has to be less than 14 plus 18. Well, this is 32. So this will not form a triangle. This will not form a triangle. You are done. Part D. All right, folks. Hopefully that helps. Great job.